Nikita. Okay, so Monday, can you get me the answer of this? Okay, for the bonus point. So Monday, to write the complete problem, and Monday you give me the answer. Okay, I have the answer with me, I will not give it to you. Okay, so that you can, it is a privilege for you. For the exam, you are 10 steps ahead of the class, not 1 step. If you do it, you are 10 steps ahead. Okay, so I don't want to waste my time, because of course wasting only, because many of you are not interested, many of you are getting bored. Even simple terms are not able to get, or they have to really struggle. So I am sure if you are interested, you can do in the class. So you get the integral evaluated, multiply by p, you get this term. This is very straightforward, and you get the good answer. Last part of this business, a equal to x plus bt, I will be doing by the direct method. Next, I will be teaching something called direct method. So we will be doing now direct method applicable for any system. And the question comes, why I did is that, why unnecessary I talk all those things? Because earlier procedures are very straightforward. You remember when I talked about the symmetric system, eigenvalues are distinct, eigenvectors are orthogonal. It's a very straightforward approach. And for that purpose, we don't even have to do symmetry transformation. Then the non-symmetric system came, and of course, non-symmetric system, if you have distinct eigenvalues, we can get eigenvectors, and we can use bi-orthogonality criteria. That can be done the first approach. Second approach was symmetry transformation. Why I taught it? Because if you have the generalized eigenvector, you can get Jordan canonical block, and Jordan canonical blocks can be decomposed to J1 and J2, and J1, J2 generally you have seen up to 3 by 2 system, J1, J2 commuting. But when you have 4 by 4, 5 by 5, or even 10 by 10 system, you have to verify J1, J2 commuting or not to apply the formula. That is a tedious system. But when you have direct method, this method is valid for anything, whatever is the line. Only thing is, this method is a bit complicated. This method is a bit complicated. But this method will be applicable for anything, whatever is actually available. So you can peacefully apply. Why it is called direct method? Because your system is dx dt equals to ax. What is the solution for this system? We know that e to the power ta into c. We have done it. This is called direct method. I directly evaluate e to the power ta. If I evaluate e to the power ta, that's it. And how to evaluate c? Initial condition is that x bar t equals to 0, which is x0. So from here, what you get? X0 equals to the power ta will be 1 is the identity matrix. So e to the power, you should write t equals to 0 into a into c, and this is nothing but identity matrix. You can go home and verify. If you put e to the power 0a, of course a is a matrix. If a is a scalar quantity, you can easily verify, say, okay, e to the power 80. E to the power 80 is a scalar quantity, t equal to 0, e to the power 0 equals to 1. Since a is a matrix, okay, so here we will see that will become, that cannot be a zero matrix, that can be a identity matrix. So in the identity matrix, one can actually have this x0 equals to c. One can actually have x0 equals to c. So your solution is x equals to e to the power ta into x0. Direct method, nothing, no hidden thing, nothing is there. It's a direct method. It is direct method. So there is no hidden thing, it is direct method. So now this evaluation of e to the power ta is big challenge. It's a challenge. Why? Because a matrix in a real matrix could be anything, could be non-symmetric. This method is applicable in a versatile manner for the non-symmetric matrix. A matrix could be 10 by 10, 15 by 15, 20 by 20, and you have to have a judicious approach to the for evaluating e to the power t. And e to the power ta, we have seen how to evaluate. So if we look at e to the power ta, which is I plus ta plus t square by 2 factorial a square, it will be infinite, right? And so many things actually we have to verify. For example, e to the power a plus b, as I said, it is not equal to e to the power a, e to the power b, unless they commute. Okay? Unless they commute. And so this type of thing we don't have to do here, direct method. Okay? This type of thing we don't have to do here, because if you look at a plus b whole square, what is the step for a plus b whole square? A square? A square plus? It is not the step. The steps what you are saying is wrong. Next step is this one. If you do that, you will be doing mistake. It is a square plus ab plus ba plus b square. Similarly, one can have a plus b whole cube. How to do that? A square plus ab plus ba plus b square into a plus b. If they don't commute, this will go like this. Okay? If they don't commute, they will go like this. So this type of things will avoid it. We will see. That's why I am saying direct method. Everything is coming direct. There is no kind of approximation and all those things will be happening here. So let's proceed for the direct method. So as I said, this is the challenge. Okay? So when introduce, so evaluation of e to the power ta is a big challenge. Why? Because the matrix could be anything. Matrix could be anything means I can give a matrix 10, 5, 75, 80, 15, 32, 9, 37, 27. Arbitrarily. Imagine that you are evaluating e to the power ta for this. You will say, I will not study material because and go home and sleep. Because what will happen? E to the power ta means I, ta, up to this okay. T square, a square by 2. T cube, a cube by 3. Will you go for infinity? 50 minutes exam will not be sufficient. 3 hours exam will not be sufficient. One problem you will struggle and you will get 0 marks because I won't give part mark. Okay. So, we have to now know how to evaluate e to the power ta very nicely, even for this matrix. So I introduce the concept of fundamental matrix. So we introduce a concept called fundamental matrix. We introduce the concept called fundamental matrix. So what we have seen, x vector can be written e to the power ta x naught. X vector is e to the power ta x naught. So what I am saying, I want to construct fundamental matrix, use fundamental matrix to calculate e to the power ta. Okay, I will construct fundamental matrix, use the fundamental matrix to calculate e to the power ta. Any vector can be expressed the linear combination of basis vector. Same thing. So whenever we have any problem, we will go to our fundamental property. So this x vector is a solution vector. This x vector is a solution vector. Okay, and we have got the basis. Say xi bar t. So you can write x bar t as c1 x1 bar t, c2 x2 bar t, and Cn xn1. These are the bases for the solution vector. And any vector can be expressed as a linear combination of basis vector. Okay.
So, should be
Any vector can be expressed as a linear combination of basis vectors. Okay, so x bar k will be what? What should I write? X bar k in a matrix form. I can write here C1 to C. What should be here? X1. This is column. X2. Am I correct? So for this X vector, this is a matrix. This is C1. So if you see, it is multiplied, right? So each element, so I am just putting a vector. Let's say C1, X1, bar to Cn, Xn bar. And then you can see this is a matrix whose columns are the solution basis. Whose columns are solution basis. So how to calculate C vector? How to calculate C vector? If you put 0, x0, and then x1 0, x2 0, xn 0. So C will be what? C will be x1 0, x2 0, and xn 0 inverse. Am I correct? Is it correct? Okay. So what will you finally get? So x bar p, which will be x1p, x2p, and xnp, and then in place of C, what you do write? x1 0, x2 0, xn 0, and so this is my final solution. Yes or no? I will say this is my equation number A and this is my equation number B. Right? This is my solution from first principle. This is my solution I am getting from here. So what is my equation for TA? This multiplied by this. Right? You compare equation A and B. Your e to the power TA will be this multiplied by this. Okay. So comparing equation A and B, comparing equation A and B, comparing equation A and B, you get e to the power TA equals to x1 bar t, x2 bar t, xn bar t, and then you have x1 0 bar, x2 0 bar, xn 0 bar, minus 1. This matrix is known as fundamental matrix. This matrix is known as fundamental matrix, which I would say MT. This I will say M0 inverse.
power ta can be expressed as mt into
M inverse mt into M inverse.
So e to the power ta is nothing but
mt into M inverse. Right? Yes?
okay.
So, and this mt is a fundamental matrix. Fundamental matrix is not unique. Fundamental matrix could be anything. But you cannot construct your own fundamental matrix. You cannot construct your own fundamental matrix. Right? One cannot construct your own fundamental matrix. Fundamental matrix should be constructed based on the independent solution. Independent solution could be anything. That's okay.
But mt could be such that mt and m inverse 0 to multiply
e to the power ta can be obtained. E to the power ta cannot be anything, because if e to the power ta can be anything, you can get any solution. That is not correct. Solution is unique. That means
mt you can construct based on your own solution basis.
I will be discussing how to get solution basis.
mt can be constructed based on your own solution basis, not a problem. And accordingly, m inverse 0 will be calculated, because m inverse 0 is obtained from mt. We know that. If you multiply this, you should get unique e to the power t. So this matrix is very important,
Which is known as fundamental matrix, which is constructed such that each column of the fundamental matrix will be having the solution basis. This is one solution basis, this is one solution basis, this is another solution basis. So fundamental matrix has the column which are having the solution basis. Solution basis could be anything. Okay? But the fundamental matrix could be such that this inverse is e to the power t.
okay? Any questions, any doubts here?
Then I can proceed for an example problem
From the assignment 5.
Any questions, any doubts?
Okay, so let's look at, so what I will do,
Next set of problem.
I will not be solving this type of system,
Because
x0,
once you find
e to the power ta, you multiply x0 1, you get the answer.
I will be rather concentrating how to evaluate e to the power t. The major challenge. That's why I said this is a challenge. Other things when I said once you get e to the power t,
You are 90% done with.
only thing is that
Multiply with x0, get the final solution.
right. So let's take an example.
And we will see how to construct a fundamental matrix, multiply by m inverse, and to get e to the power t.
So let's take up a problem. Our problem is
Minus 3 to 0, 0 minus 3 1, 0 0 minus 2.
very bad problem I have taken.
Eigenvalues are all same. Without calculating, you can see the eigenvalues. They are all minus 3. You don't need to calculate. Okay?
And matrix is also non-singular. It is not a singular matrix, non-singular matrix. Okay. So now we have to evaluate the solution basis. So your job is, so the question is, evaluate e to the power ta by a fundamental matrix. It's not the e to the power ta. One can actually, what you can do, you can say, sir, my e to the power ta I can easily calculate. How? E to the power, how to do that? P e to the power. Am I correct? I won't ask. I am not asking for that. This method I am not asking. I am asking direct method. This method is asking that, then why are you doing so much things? I am not asking for that. I am saying that this method I am not asking. I am asking to construct the fundamental matrix. That means we have to calculate MT, and then e to the power ta will be MT and M inverse.
different matrix based on that. No need to have generalized eigenvectors and all those things. I don't know. Now, how to do that? Your differential equation, if you look at your last so from here you can write dx1 dt equals to minus 3x1 plus 2x2. dx2 dt equals to minus 3x2 plus x2. And dx3 dt equals to minus 3x3. Okay. So from this last equation, what do you get? x3 equals to I'm saying the integration constant is c3 prime. Okay, 3 and 3, that's what? E to the power? Excellent, very good. Now coming to the same next equation, dx2 dt, which is minus 3x2 plus c3 prime e to the power minus 3t. It is dy dx plus py equals to q time. Right? How to get the x2 from here? Integration constant will be nothing c2 prime. c3 prime is already there. What is the integrating factor? E to the power 3t. Excellent. Correct. E to the power 3t. Integrating factor is e to the power 3t. What are you getting x2? What are you getting x2? What are you getting x2? Integrating factor is obtained already. You tell me the integration constant is c2 prime. What is that? x2 equals to c2 prime. Yes, you are in the right direction. c2 prime e to the power minus 3t, then c3 prime e. Excellent. Thank you. Then go to the last equation, which is dx1 dt. So plug it in the x2, which is c2 prime e to the power minus 3t plus c3 prime e minus 3t. Do the very careful calculation, and integrating factor also again you have to obtain, and finally what you are getting? x1. Finally what you are getting? x1. x1 equals to x1 equals to x1 equals to x1 equals to any idea? Okay. What are saying c1 prime e to the power minus 3t plus 2c2 prime t plus 2c3 prime t square by 2. I am assuming that my simplified constants are c1 prime equal to c1, c2 prime equals to c2, and 2c3 prime equals to c3. Now you can see why I use prime. So I can get a very clean equation, which is x1 equals to c1 e to the power minus 3t plus c2t e to the power minus 3t plus c3 t square by 2 e to the power minus 3. Very clean equation. Similarly, x2, x3 can be obtained. Now, I will show you how to construct the solution basis. You saw the solution x1, x2 and x3. These are my solution. So it is possible to write x bar t, which is x1t, x2t, and x3t, which is, you can write c1 into e to the power minus 3t. What you can write x1? It is 1. x2, c1 is not there, right? x3, 0. Plus c2, we can have e to the power minus 3t again. What is that? What is that? t next. 1 by 2 next. Excellent. C3, e to the power minus 3t again. D square by 2, 1 by 2 or t by 2? 1 by 2 and 1 by 2. Can you construct M matrix? You think I can do it, but I will ask you to think for 1 minute. So you can give me the answer and you will be happy. M matrix is constructed such that each column of M matrix is the solution basis. Now we can see what is solution basis. This is the basis, this is the basis, this is the basis. Of course, it is by minus 3 you have to incorporate. You cannot neglect. Basis means this is the constant only. Other things are variable. Okay? So what will be your MT? E to the power minus 3t, like column wise? 0, 0 next. T minus 3t. Then next? By 2. Okay. E to the power minus 3t. 0 next. T square by 2 minus 3t. T by 2 minus 3t. Minus 3t. Excellent. You understood what is called Cartesian matrix? Clear? M inverse 0. First, to calculate M0, which is very easy, which is 1, 0, 0, 0, half, 0, 0, 0, half. And that's the beauty of M. M0. M0 is always diagonal matrix. So, M inverse you know that. Reciprocal will be that. So, calculation is very straightforward. What is M inverse 0? 1, 0, 0, 0, 2, 0, 0, 0. It was initially not very difficult because we take M0 M inverse. Now M inverse 0 is very easy. Now we have to multiply MT and M inverse 0. And what you get? What you get? E to the power t8, which is MT M inverse 0, then e to the power minus 3t 2t minus 3t t square minus 3t. Next is 0 e to the power minus 3t t e to the power minus 3t 0 0 e to the power minus 3t. Okay, this you keep. Now we have to know whether this is correct. How to verify this is correct? Yes, got it. Because always you have to verify. Not in the exam, but initially you are learning the technique. Exam you don't have to verify. If you want to verify, then gone. Then why do you do this thing? You can directly go for your own. Okay? So how to verify? What is the P matrix? What's the P matrix? So this technique I'll be doing different. I'll be addressing many of the things about this technique, because if you look at this problem is a special problem, because if you look at hard differential equation has only one term.
dx dt 3 dt equal to 3x3, right? You could have asked me a question, sir, if all terms are on, how to handle this technique? So that another technique is called as eigenvector decomposition technique, event rooted solution basis. That I am going to discuss. Before that, what I want to do, I want to verify e to the power t. I want to verify e to the power t, which is equals to e to the power jt p inverse. What is my p matrix? 0 0 1. P matrix. First eigenvector is very straightforward. We have done this kind of eigenvector which is geometric basis. First eigenvector is geometric basis. What is that? First eigenvector is geometric basis. What you got? Nikita, right? Your name? Yeah. What you got? What are you doing? It is very simple. How much you got? Abnesh? 1 0. How did you get? How did you get 1 0 0? A minus lambda, yes, huh?
All three are zeros.
Yeah, that we have discussed already in the class. Next eigenvector is generalized. Next two will be generalized, right? What is that next two eigenvectors? What is the next eigenvector? Next. You give me the answer, I will put there. Third eigenvector. Third eigenvector.
0.
No. R is given as eigenvector constructed from the Q1. Third eigenvector is given as eigenvector. You should not be doing this time. So much time you are doing this problem. You should not be doing this. How much time I am actually getting, I am wasting. If calculate how much I huh?
0 half.
0 half is not correct. 0 will not be there. Huh? I'll give my answer. You go and verify. You go and verify. Okay? Half. That's why I'm saying, you are not able to do it properly. Use this. What is P inverse? That you can calculate, but you need to calculate because otherwise you cannot get into the T. So we have to calculate now, sir. Otherwise you cannot get into the T. You have to calculate now. You cannot skip here. You cannot skip. You have to calculate P inverse. P inverse Yes, have you got P inverse? What? Who will give me P inverse? Column wise you are giving? Okay, column wise. Okay, next. Minus? Minus 2 to? What is that? 0. Minus 0 cannot be. 0 and minus 0 both are same. Next? Minus 2 is not correct.
0 minus.
Not correct.
0.
P inverse you are doing. Don't ask me how to calculate P inverse. There are so many ways. We can go by adjoint method, we can go by the method what I discussed today.
So 1
Yes.
minus 2.
So many numbers I am getting. Simple P inverse I have to struggle so much. If you cannot calculate P inverse, your equity will be wrong.
0 0 2. 1 minus 2 0. 0 2 minus 2 0.
1 0 0 is correct. Minus 2 up to this much is correct.
Minus 0 minus 2 minus 2. 0 minus 2 2. 0 minus 2 2.
My God, I'm just really surprised that after this, how to do all this calculation correctly. P simple P inverse you are not getting correctly. Whatever P inverse you are just coming, just see this matching I. You should get identity matrix, no? Somebody is getting 1 minus 2 2. See, so many answers I am getting. I am now getting confused. I am now getting confused. One minus 2 is already given to me. Something else. Simple P inverse I am asking, I am not getting. Simple P inverse. No, fast. Simple P inverse I am not getting. People can evaluate up to 2 columns. That is of no use. We have to evaluate all the columns, otherwise problem. Okay, the answer is 1 2 2. The answer is 1 2 2, and you can verify if you multiply P inverse P inverse or P inverse P should be I, identity matrix, and the J matrix will be what? Minus 3 1 0 0 minus 3 1 0 0 minus 3. The J matrix. And then what will be J1 J2? It will be minus 3 0 0 0 minus 3 0 0 0 minus 3 plus 0 1 0 0 0 1 0 0. Okay? And I am assuming that this J1 and J2 will commute. You can verify. Okay? So in that case, e to the power Jt, you can do it from your previous calculation. Can you give me the answer? Just now we have done it. E to the power minus 3t minus 3t e square by 2 to the minus 3t 0 e to the power minus 3t e minus 3t 0 0 minus 3t. Last step is now remaining, which is p e to the power jt p inverse. I am sure you go home and get the answer and get this e to the power pa verified from here and there. Okay. Next class I will be solving the same set when the solution basis can be done in generalized manner. Because your last equation, if you look at your last equation, had dx dt equal to 3x3. If it is having all x1, x2, x3, we cannot do it so simply. Okay, in that case, again we will be using eigenvalue decomposition to get the solution. But we will see how to get it done to get solution basis. Thanks for your kind attention.